Video 11. Vertical Alignment Optimization.
So we've got a roughed in horizontal alignment, and our next stage is to really let's reduce our earthworks as much as possible. So I'm going to drop this down here. That makes sense. It'll all help. And we're going to add our constraints in. Now, for this, we're going to go to our Project Explorer panel, add vertical alignment. I'm going to call this spacing 20. I'll say vert. We'll use our initial alignment as our starting point. We are going to put in our constraints. So right now I'm going to use fast curves. I'm going to allow the minimum and maximum grades to be 10% and set my minimum maximum curvature to be k's of 5. I'm just going to turn this on. So this is a version 11 feature as well. I'm going to add a control point at the start of my alignment. Our costs we've already accounted for. We could add in constraints if we expected things like material movement direction constraints. So say end dumping or end haul material. We don't have any here. We don't have any spots where I need a minimum fill height, full bench spec, and I'm not going to worry about side cast, at least not yet. And next I'm going to go through here and I'm going to get my stationing for where I can encounter these pads. And I'm doing that because I don't want these pads to be on a 10% grade or have a curve through them. So let's start at the start and go to the end. So at station 380, we want to start a pad. And by station 560, we want it to end. Add 1. So in here we will start at 1656 and carry that forward to 1756. We'll do the same here. And just this line work that's popping up is doing so because I didn't allow it to recalculate, just because I don't really care to see everything rendered properly right now. $21.36. $34.35 to $36.20. And then we've got $42.34 to the end. So let's enter those constraints before we run this. So I want a minimum grade of 2%, maximum grade of 2%, and I want them to be linear. And that's from 380 to 560 for the first one. I want to have 1656 to 1756 for the next one. We'll go 1957 to 2136. We'll go 3435 to 36200. And then we'll go from 4234 to the end. So let's let this run. And we can see here it's ran. We'll hit OK. We're going to see our alignment is wavy. We used fast curves, so we've allowed curves to be butted right up against each other, but it gives us the cheaper solution. So there we are. We can see what we're working with. We can look at our mass hull, see where all our material's coming from and going to. And there we are. And we've got a big surplus here. Deficit there, deficit there. Now we could refine this. We could move things around and we could say, well, the surplus, could we maybe spoil our material? And the answer is yes, we could. Is there anything we can do to realign? Well, this one kind of looks pretty hemmed in, short of moving our tower site. We can continue along. We'll check for other spots where it might make sense to improve things. Happy with that. Happy with that one. That looks reasonable. And this one, it's on solid rock, so we probably don't want to blast if we don't have to. Now what we could do here is we could say, well, let's borrow some material. Just take our superficial material and use that for subgrade here. So sure, let's add in some borrows. Looks reasonable to borrow from there. We could design it if we'd like. I'm just going to add it in as a potential pit. So we've got one borrow added there. Now here I'm going to assume we can spoil that material. So So we can add a spoil site, and it doesn't look like there's any issues if I spoil right there. So we can move that extra material from our pad there. And the remainder, if we're creating any surplus along our road, I just want to allow it to disappear, that extra material, where it's appropriate. So this will be my side casting. So I'm going to add that side casting constraint in. I'm going to tell it, let's allow it to side cast up to 5 cubic meters per linear meter of road. We can specify where that actually takes place here. We're going to just add that in here. We'll hit OK, and we're going to run this again and see if adding those borrow, spoil, and side cast constraints, 1, help us reduce our costs, and 2, give us a little bit better geometry. And just backing up there, we could have absolutely twisted things around if it made sense to, but I think we did a pretty reasonable job positioning things to begin with. So we've gone from our previous cost to a new cost of $720 instead of $735. So we saved a little bit of money, not a lot. If we take a cruise through, we can see what's happening in our mass haul. But the mass haul is not telling us the full story. If we want the full story, we can go in here and we can look at the opti haul. So here we can see where we're side casting material, where we're end hauling our material, and where we're just using that free haul movement. And if we hover over these, we can see that, well, in that location we're moving it all in one direction, but up here we've got a hard pan moving backwards and solid rock moving ahead. So it gives us a really detailed breakdown of what's what.